Hello students, in this video we are going to study a new concept called deadlock. So what is a deadlock, or what is the definition of a deadlock here? A deadlock is nothing but it is a situation where each of the process or where all the processes or some processes are going to wait for a certain resource. Okay, to execute the certain process, it is going to wait for a certain resource. That resource is being assigned to some another process. Are you getting that resource? Whichever it want know that process, it has been held by the some other process. So in this situation, none of the processes are going to be get executed, since the whatever the resource it needs that is held by some other process, okay, which is also waiting for some other resources. Okay, so whenever that resource is going to be released, then only that particular process is going to be executed. So this waiting period is going to be a infinite time, or there is no time limit. So hence this situation is called as the deadlock. Are you getting? A deadlock is a situation where each of the processes are going to wait for a certain resource. That resource is held by some other processes, but to execute that process, that resource is necessary, getting, and that is held by the some other process. Okay, that is that is held by some other process, and that resource is working for the some other, that process is working for the some other resource. Okay, so that is nothing but the deadlock. So as you can see on a screen here, so there are two processes and two resources. So in this diagram, so there are two processes, process 1 and process 2. So process 1 is already having the resource 1. Okay, so that connectivity arrow mark you can see, the process 1 is already has the resource 1, and it wants resource 2. Okay, the process 1 is already acquired by the resource 1, and it still wants resource to execute that process 1. So similarly, process 2 has resource 2, and it needs resource 1 to execute that process 2. So here in this situation, the process 1 and process 2 are going to be in a deadlock. Why? Because both processes are both processes needs here both the resources, that is resource 1 and resource 2. Okay, so to complete the process 1 and process 2 execution, neither the process 1 and neither the process 2 are going to be executed, because the process 1 is holding the resource 1 and process 2 is having the resource 2. But to execute both the processes, we require both the resources. Okay, for at same time, you have to remember, at same time the different processes are wants to use the resources. Okay, so that is nothing but the deadlock. So this is an example here. So a process, how the process is going to use resources. So there are three sequences. A process is going to use the resources. How? Okay, how the processes are going to be used, how the processes are going to use the resources. So there are three sequences. One is it has to request first. So if the request cannot be granted, then the requesting process it has to wait until it acquire the resource. So after getting or after granting the permission, it is going to be means the resource is used by the processes. So after using the resources by the particular process, it has to release. So why it is going to release? The some other process also wants that particular resources. Clear? So after that, so there are four conditions or the characteristics of deadlock, or even you may call it as a Kaufman conditions. Okay, so a deadlock, it has to satisfy the these following four conditions. One is mutual exclusion. So it is already we have studied a mutual exclusion, right? So while explaining the critical section, we have already studied the mutual exclusion. I hope you remember that. So what is the mutual exclusion here? The only one process at a time can use the resources. Okay, no other processes can use the resources at the same time. This is nothing but the mutual exclusion. Only one process at a time can use the resource. So if another process requests that resource at the same time, the requesting process must be delayed, or it is going to be a wait until the resource is going to be released by the particular process. Okay, means no two, in short, what is mutual exclusion, what it tells here, no two processes can use the same resource at a same time. Clear? So the second is hold and wait. Okay, what is hold and wait? As the name itself implies here, that a process can hold the multiple resources. Means, as I told in while explaining the deadlock with an example, there are two processes, resource 1 and resource 2. It means what? Hold and wait means what here? A particular process or any process can hold, or it may have the multiple resources. It can work on the more than two, that is multiple resources, and it can still, if the process is having already two or more than resources and still it wants to acquire, or still it is requesting for the some more resources from the some other processes, and that processes which are held by the some other resources, getting hold and wait. So it means what here? A process may have the multiple resources and still it is requesting for some other or more resources from the some other processes which are held by the some other resources. That processes are already held by the some other resources. Here the process is going to wait for the resources. Clear? So while holding another resource at the same time, a process can waits for a resources while holding another resource at the same time. So this is the second condition. So third is what? No preemption. So no preemption, already we have we are familiar with the preemption word. So in this, no preemption means what? The resources cannot be preempted. That is, resources can be released, or only the resources when we are going to release, or when we are going to release this from the execution, when that particular process completes its execution. No preemption means, preemption is what? In middle we can interrupt the execution. So no preemption means we cannot interrupt here. So resources cannot be preempted. So once the process already has acquired by some other resources, so in middle we cannot preempt it. So a resource can be released only voluntarily, means only willingly, according to its wish, by the process after that process has completed its task. Okay. So what is circular wait? So circular wait, so as the again here the name itself indicates, only one line has been displayed here. So sorry. So circular wait, I'll explain, just listen carefully. So it is circular wait. So there exists a set of waiting processes. There may exist a set of processes, means a collection of waiting processes. Okay, not a common or normal process. There may exist a set of processes. For example, as you can see here on the screen, P0, P1 up to Pn. So P0 to Pn, it is a set of waiting processes. So here the P0 is waiting for a resource. The P0 is waiting for a resource that is held by the process P1. Getting? In this, there exists a set of waiting processes, that is P0, P1, P2 up to Pn. So here the P0 is waiting for a resource that is held by P1 process, and similarly P1 is waiting for a resource that is held by the P2. Getting? The P0 is waiting for a resource that is held by the P1. P0 is waiting for the resource that is held by the P1, and similarly P1 is waiting for a resource that is held by the P2, and similarly P2 is waiting for a resource that is held by P3, and so on. So here we can say the Pn, that is Pn minus 1 is waiting for a resource that is held by the Pn. Okay. So and what about Pn here? The Pn is waiting for a resource that is held by the P0. So this is the circular wait. Again, these 4 conditions are very important for your exam purpose. So they may ask, what do you mean by deadlock, for 2 marks, and even these conditions are important for your 5 marks, or they may ask in the 5 marks that define the deadlock and explain the characteristics of deadlock. So in that condition, for that problem or for that question, you need to answer this much. Clear? Thank you.